Okay, hello again. This week's subject, torsion. And as we discussed in week 6 about shear stress, also in this torsion twist case, the stress is shear stress. And let's see what I have written in each learning environment. And this picture is very good. There is almost everything that you have to know or calculate. Torsion or twist moment affects in this shaft, and it causes a shear stress during the torsion. And the most important formula is this one. Shear stress is torque per section modulus torsion. And so M per W when you calculate the shear stress in this kind of situation. And of course, when we twist shaft, it affects the twist angle in this shaft. And these are the most important calculation that we use when we have this kind of torsion moment. And this formula tells the maximum shear stress in the surface of this shaft. But we can also calculate in whatever part in this shaft the torsion, but in strength theory we always want to know the maximum value, and this formula gives the maximum value automatically. There are other things that we'll calculate is the angle of twist, and there are a couple formulas that we can use. This formula can be used only if the object is round, but this formula can be used any kind of cross sections. And as you can see, the unit that comes from this formula is radius and radian, and also in this formula the unit is radian. And I recommend always to use this formula, because then it can be used also around cross section objects. If you want the unit to be degree, you have to use this extra part. So you put 180 degrees per p. And also in this formula, you can change the unit to degrees same way. Okay, let's see. Let's see these problems that we have today. Firstly, as you can see, the number of this problem, normally we have numbers 1, 2, 3, 4, and so on, but here is V5, and that's because when you look the parametric table, you have to find the V5 from somewhere. Oh, this is wrong parametric table. Let's change. This one. So when you calculate, you have to look this V5 and the next one, I think it's this V6. Let's see. Yeah. So the parametric table values are from the row V5 and V6. Okay, the first problem. With what force does the screw need to be turned? F. So you have tool, and here's the screw. And firstly, you have to calculate the force F to get the torque moment to the screw, and you can find the needed torque moment from this column. And this is from standard what torque moment you should use to each type of screws. Then the next question, what kind of shear stress is then created on the bolt? And yet, what is the safety factor in relation to the yield strength of shear? So this is the first exercise, and the second exercise is determining the shear stress of the material, the shear stress caused by torsion, the angle of twist, and the yield certainty, so safety factor. And there is also formula that you can use, because this is the Young modulus, and this is twist modulus. So this, with this calculation, because in this parametric table you have only given this Young modulus, so you have to calculate this shear modulus with this formula. Okay, now I change to my iPad. Let's see the material. We start from here. What's very convenient, all the formulas that you need in this section you can find from this technical formulas book in one page, all these important formulas. But I noticed now that I have not, it's not complete picture, that I have to take another one. Try to take a better picture. Try again. Okay, now it's complete. So all these important formulas is in this same page, and as you can see, there is this same picture also as in the e-learning environment. And the most important formula is in here. But as you can see in this page, it's divided in two sections. So this upper section is when torsion of solid circular bar, and this lower section is said that cross section is not circular. But as I said earlier, you can always use these formulas, because with these formulas you can also calculate circular bars, and that's why I recommend that you use always this lower part of this page. So use this one, and then you can take the wrong formulas at all. Okay, let's go to this problem. The first one was to calculate the force that you have to use, this force F, to get enough moment to the bolt. And what you have to do, you have to check from this parametric table what kind of bolt is used. Let's say it's M10. Then you have to check from this column what kind of moment should be used to tighten the screw. So that was the first calculation. And of course, to get enough torque, the formula that you have to use is very simple. Force times distance. And when you have found the right torque, and look from parametric table the distance. You can calculate the force needed to get the torque. So very, very simple. The next thing is to calculate the shear stress that is created in the bolt. And then you use this formula. So tau max is torque per cross section of torsion. And because this bolt is circular, then you can use either this upper part of this weight, or you can use this lower part. Either one, you can see that this formula is same in both cases. And as we thought earlier, what is the cross section of this bolt? You have to use, this is the screw, and the diameter of the screw is not this outer diameter, or it's either this core diameter. So the diameter that you use to calculate this W, you have to use this formula to calculate the diameter. Then you can calculate using this one, pi times diameter power 3 per 16. And then you get this section modulus in torsion. And because you know this one from this parametric table, then you can easily calculate the shear stress in this bolt. And these pictures are, I have shown you this earlier. This is normal stress diagram. This is normal stress. And this is actually diameter of structural steel. And here is the Young modulus. And this is diagram for shear stress, and the angle is not Young modulus, but it's this shear modulus G. And to calculate, because you have only in parametry table you have this Young modulus. You have to calculate this G, and the formula for that, where I have put it. Okay, in this it's in the next problem. So now you have calculated this one, and the next question is, what is the safety factor in yield strength of share? So next one, you have to calculate the yield strength of share, and as you can remember, material strength in share is not as good as in normal force. And I did show you this atomic picture and told you why it is so. But here is how you calculate, because you have to calculate this one and to get to this one, 0.6 times normal stress is the shear stress. But you have to first calculate this normal stress value, and you can calculate this because there is shown somewhere. I have forgot to put it, but here it is. Strength class of this bolt is 8.8, and it means that ultimate strength is 800 megapascals, and this 0.8 means that 0.8 times this ultimate strength is the yield strength. So when you have this calculated, you put it in here, and then 0.6 times this yield strength of normal force is the yield strength of shear stress. Okay, now you have calculated this one, and the last thing is put it in here, and the value you have calculated in here is the real value in volt, and then you can have this safety factor. Yeah. You can see also here how it is calculated. Okay, you don't use this one in calculation, but you have to calculate this one and the formula for this section modulus in torsion formula is in here. Then we take the next one. And this is the classic problem solving in torsion. Determine the shear stress in the material, shear strain of the material. So this one is the first one to calculate. And you can find the Young modulus on the parametric table. And this is Poisson value. Poisson value tells the thing that when you, for example, pull a piece of shaft, it lengthens and in sidewise the diameter diminishes at the same time, and it is this equation between the lengthen and the diameter diminishing is this Poisson value, and it's something between 0 and 0.5, and typically with metals it's something like 0.3, 0.35. So this is the first one to calculate. You can find it from here also. And then shear stress caused by torsion. So you can find from this parametric table the torsion. And again, you have to calculate let's put it like here. First you calculate this one. Then the next thing to calculate is I have a little bit too small table. It's hard to write. The next thing to calculate is shear stress. Then you calculate the angle of twist, and the last one is to calculate the safety factor. I check those values, they are correct. in this order and use, okay, you use this formula for this one, and then you use this formula for this one, and then you use I recommend that you use this one for calculating the angle of twist. But as you can remember, this gives radian values, and if you want to have degree values, you have to put this multiplier here, and in parameter table it's the answer is a decrease, so you have to use this multiplier to calculate the angle of twist. And what was there? Was there something else? Yield certainty or safety factor was the last one. And I show you in here somewhere. You use this one. And as this earlier exercise example, you have to calculate also at the same way this torsion yield strength to get this value. And this value is what you have calculated in here. Now let's copy something there still. This one. And that's all you have to do to calculate or solve this problem. Okay, hopefully you can manage with these tips and get the solutions